Hello and welcome to another video for pre-calculus. In this video, we are going to start looking at trigonometric functions. So there are two different approaches to define trigonometric functions. So one is using the right triangles, and the other approach is using the unit circle. Both are same thing. I mean, it's just different approach to see things. So first, in this video, we are going to discuss about the trigonometric functions. So just define the trigonometric functions using the right triangles. And in the next video, we'll define the same thing using the unit circle. So before I move on to the definition of these trigonometric functions or the ratios, one important thing that we need to know is kind of like a convention when we look at a triangle. So if let's say we have a triangle, okay, let me draw the triangle. So usually we use the letters to represent the vertices. So we use uppercase letters, let's say A, B, and C. So we use the uppercase letter to represent the vertices of that triangle. And then that letter represents the angle. Okay, so corresponding angle right here with that vertices. So B, if I write angle B, that means I understand this angle. And if I write angle C, I understand this angle. So if you just see, it says angle A. That means if you have that uppercase letter, that means that is angle A, that angle on at that vertex A. Now, to denote the side, we use the lowercase letter, and the way that we denote the side or represent the side is the side opposite from angle A. So, which is this side BC. Side BC is represented by lowercase a. And then the side opposite from angle B, which is this side AC, it is represented by lowercase b. And the side opposite from angle C, this AB, this side is represented by lowercase letter c. So that's how, so we use the lowercase letter to denote the sides and the uppercase letter to denote the angles. And then it's very important that the side opposite from angle B is lowercase b. That side is, the length of that side is b. Okay, so that's what we use. So just remember that one. Now let's consider a right triangle. So a right triangle is a triangle with one of the angles is if one of the angles is 90 degrees. So this is a right triangle, and then 90-degree angle or the right angle we denote by that small square at the vertex. Okay. So now a couple of things here. So let's say we are considering this angle. So let's say that is theta. So that angle is the reference angle. So we are defining trigonometric functions based on that angle. And then the side opposite from the right triangle, so right angle is called the hypotenuse, is the longest side. And then the side that is attached to that angle is the adjacent side, and the side that is away from the angle of, or on the opposite side of the angle, that is called the opposite. Now in trigonometry, we have 6 different trigonometric ratios, or we call them functions. So those are sine, cosine, tangent, cosecant, secant, and cotangent. So that's the name. And then we have the abbreviation for them. So for sine, 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 we make it short and write as SI and sine. For cosine, we write COS. For tangent, we write TAN. For cosecant, we write CSC. For secant, we write SCC. And for cotangent, we write COT. So those are the abbreviations to represent those functions, okay? Now we will use this right triangle and the angle in the right triangle to define this function. So these functions are nothing but they are the ratio of sides. Okay, so for example, if I am taking this angle theta and saying sine of angle theta, or the sine function of that angle is opposite, so sine is always opposite over hypotenuse. Okay, then cosine of angle theta is adjacent divided by hypotenuse. So tangent of the theta is opposite over adjacent. Cosecant is hypotenuse over opposite, or it's just the reciprocal of sine if you look over here. So sine is opposite over hypotenuse, and cosecant is the reciprocal of that because it is hypotenuse over opposite. Again, secant is the reciprocal of cosine, which is hypotenuse over adjacent, and then cotangent is reciprocal of tangent, which is adjacent over opposite. So there's a shortcut, shorter way to represent this, which is very common. You might have heard about that before. So which is called SOHCAHTOA. So here S represents sine is opposite over hypotenuse. cosine is adjacent over hypotenuse, and TOA means tangent is opposite over adjacent. Now, for cosecant is the reciprocal of sine, secant reciprocal of cosine, and cotangent is the reciprocal of tangent. So once we remember those three, we know the other three because they are just the reciprocals. Okay. So these are the six trigonometric ratios, or we call them trigonometric functions. So this is sine is a function of that angle theta. So if it is sine theta, if you write sine theta, that means sine as a function of theta. So now it's very important that we just don't write sine equals something over some. That does not make sense. So it's just like function. So remember, when we write function, just like any function, logarithmic function, we write log of x, or f of x, we denote some function f of x. So it's very similar here. If you just write log, and then if you don't write log of anything, that does not really make sense when you write it. So it's a function. So we have to write sine of what? Sine of x, sine of y, sine of a, or theta, or beta, or whatever is that angle. Okay. So we have to write sine theta, or sine of something. We just don't write sine equals opposite over hypotenuse. That's not, we say that just to remember, but we don't write it that way. Okay, so it's very important that you have to have something after sine. Now let's use this right triangle, and let's write different functions, six trigonometric functions based on that right triangle. So we have two different reference angles. First one is alpha, so we are going to write all six trigonometric functions for that angle alpha, and then we'll do similarly for beta. Okay, so now if you are considering angle alpha, so if you are looking at this angle, then for this angle, this is the opposite, 5, because that's opposite from that angle. And the side opposite from the right triangle, this is obviously hypotenuse. And the side that is attached to that angle and it's not the hypotenuse, so that is the adjacent angle. Okay, so we have O, A, and H. Now we can find, so for A, so sine alpha, we know the sine is O over H, so that is 5 over 13. Similarly, the next one, let's write cosine alpha. So cosine alpha equals, so cosine is adjacent over hypotenuse. So here it is 12 over 13. Now let's write tangent of alpha. So that is opposite over adjacent. So which means 5 over 12. Similarly, cosecant alpha is hypotenuse over opposite, or it's just the reciprocal of sine. So once you have sine, you can just take the reciprocal of that, which is 13 over 5. Now secant of alpha equals, so it's the reciprocal of cosine, or it is adjacent, hypotenuse over adjacent, so it is 13 over 12. And similarly, cotangent is the reciprocal of tangent, or it is adjacent over opposite, which is 12 over 5. So that is for angle alpha. Now, if we consider angle beta, then those things change. Hypotenuse does not change, but the opposite and adjacent sides change for angle beta. So if we take angle beta, then the opposite side for that one, so for angle beta, opposite side is this one, and adjacent side is this one. The hypotenuse does not change. So this is normal adjacent, this is normal opposite. So it depends on what angle you are taking. Okay, they change adjacent and opposite. Now for angle beta, so sine beta equals, so sine is opposite over hypotenuse, so that becomes 12 over 13. Now cosine beta equals adjacent over hypotenuse. Tangent beta equals, so tangent beta is opposite over adjacent. And then cosecant beta is hypotenuse over opposite, or just the reciprocal of sine. And then secant beta is the reciprocal of cosine, or it is hypotenuse over opposite, sorry, hypotenuse over adjacent. And then the last one, cotangent, is the reciprocal of tangent. So cotangent beta equals reciprocal of tangent, which is 5 over 12, or it is the adjacent over opposite. So that's how we find the different trigonometric values for the given angle. Okay. Now I already mentioned this one. So there are the reciprocal. So cosine theta equals 1 over sine theta, or we can also write sine theta equals 1 over cosecant theta. So cosecant is the reciprocal of sine, secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. So now if you know sine, then you can find cosecant, it's just the reciprocal. If you know cosine, then you can find secant. And if you know tangent, then you can find cotangent. So they are just the reciprocal. So basically, if you know three of them, actually, if you know two of them, then you can find all other. We'll talk more about that later, okay? Now, we know we can use a right triangle to find the values of angles for that right triangle using sides. Now, let's go ahead and find, so what is the value of sine of 30 degrees or cosine of 30 degrees, cosine of 60 degrees, so when you're given particular angle. We'll look at the unit circle later, and we'll look at the table, and we'll know a lot of values. We'll use calculator. But now, just in this example, I just want to show you how can we find, just using a triangle, the value of these trigonometric functions of those angles, okay? So what I'm going to do is I'll take a equilateral triangle. So now you know that equilateral triangle means all the sides are equal. So let's say all the sides, the length of the sides is just 1, 1, and 1. So another property of equilateral triangle is all the angles are equal and they are 60 degrees. So this angle is 60 degrees, this angle is 60 degrees, and this angle is 60 degrees. Now, there's another property, very important property that we are going to use here is if I draw a perpendicular from the opposite vertex to the side here. Now, what that perpendicular line does is it divides this side into two equal halves. So the length of the side was 1, so now this becomes 1/2, and this one becomes 1/2. And also, not only that, it also bisects the um, angle right here. Now this one becomes 30 degrees, okay? Now what we are going to do is we are going to just take 1/2 of this triangle. So I'm just going to erase this part of the triangle so that we don't get confused, okay? I'm just going to take that right triangles. Now we know that we have the length for two of the sides. So I have one here, 1/2. Let's go ahead and find this side, okay? This is a right triangle. I know this is 30 degrees, this is 60 degrees, that's 90 degrees. So that means this side can, let's say it is x, and we can find x equals square root of 1 squared minus 1/2 squared using the Pythagorean theorem. You know that it is c squared equals a squared plus b squared. And then if you're finding a or b, then you subtract from the hypotenuse squared. So that's what I did here. I know you already know this one. So now if I simplify this, this is 1 minus 1/4, or it is 3 over 4 square root, and then square root of 3 is square root of 3 over square root of 4 is 2. That means this side, this unknown side, or this perpendicular that we drew, the length of that side was square root of 3 over 2. Now we have all the sides, and we have all the angles. Now, what we are going to do is we are going to find what is the value of sine 30 degrees, sines, and all the six trigonometric function for 30 degrees. Okay, so sine 30 degrees equals, now if you're taking 30 degrees this angle, so if you're taking this angle, then this is the opposite, this is the hypotenuse, and this is the adjacent. So sine is opposite over hypotenuse, so 1/2 divided by 1 is just 1/2. Similarly, cosine 30 degree is adjacent over hypotenuse, so which is square root of 3 over 2 divided by 1, which is just square root of 3 over 2. Now, tangent 30 degrees is opposite over adjacent, so 1/2 divided by, so it is 1/2 divided by square root of 3 over 2, which gives us 1 over square root of 3, okay? Now, the cosecant of 30 degrees is just the reciprocal of sine, which is 2. Then secant of 30 degrees is reciprocal of cosine, which is 2 over square root of 3. And then cotangent of 30 degrees is the reciprocal of tangent, which is square root of 3 over 1. So that is for 30 degrees. Now for 60 degrees, we can do the same thing. We'll take this angle 60 degree now. So when we consider this angle, this is opposite, this is hypotenuse, and this is adjacent. So if we find sine of 60 degrees, then it is opposite over hypotenuse, which is the square root of 3 over 2 divided by 1, which is the same thing. Now cosine 60 is adjacent, so for 60 degrees, this is the adjacent, so 1/2 divided by 1, which is just 1/2. And then tangent 60 degrees is opposite over adjacent, which is 1/2. So sorry, opposite over 60 degrees is square root of 3 over 2 divided by 1/2, which is just square root of 3. And then now for cosecant 60 degrees, reciprocal of sine, which is 2 over square root of 3. Secant 60 degrees is the reciprocal of cosine, which is 2. And cotangent 60 degrees is the reciprocal of tangent, which is 1 over square root of 3. So this is how we can find the values for 30 degrees and 60 degrees. Similarly, we can do for 45 degrees and other spatial angles. Okay, we have some certain spatial angles that we really want to look at. Okay. But we're not going to do all of this for every angles. What we are going to do is we are going to now look at a table, okay? And then later on in the next video or next section, we'll look at the unit circle. So now we'll look at a table. I'll show you a table. Before showing you the table, I just want to give you a small trick that we can make our own table. We don't have to do a lot of math for that, okay? Just there's a small trick for making our own table for the values of trigonometric function values for 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. And these are called spatial angles in the first quadrant, okay? So now this is how we are going to use that small trick to write this table. And you can do this anytime you want. You don't have to memorize this. You can just make your own table. Okay, so this is the trick here. What we are going to do is we are just going, so we have 0 degrees, 30, 45, 60, and 90. So we are going to find sine, cosine, and tangent for those angles. So what I do is I just put 0, 1, 2, 3, and 4. I just write those numbers, okay? And then I divide everything by 4. And then I take the square root of everything. So when I do that, I get the values for sine. Okay, so this is how I get the values for sine. So 0 divided by 4 is 0, square root of 0 is just 0. So sine of 0 is just 0. Now here, square root of 1 is 1, square root of 4 is 2, so this is 1/2. So that means sine of 30 degrees is just 1/2. Now here is square root of 2 is just square root of 2. Square root of 4 is 2. So square root of 2 over 2 is the value for 45 degrees. Okay, so square root of 2 over 2. Sometimes you could also you also see this one. So it was 2 over 4 square root. So sometimes people write it a little bit differently. So 2 over 4 is 1/2. So the square root of 1/2. So square root of 1 is 1, square root of 2 is 2. So if you see this one or this one, they're exactly the same thing. This is not rationalized. So if I rationalize the denominator, I get exactly the same thing that I have here. Okay, so they're equivalent. I mean, they're equal thing. Sometimes you might see in this form, sometimes you might see in the other form. So both are same. So let me just write both here. Okay, so either it is square root of 2 over 2 or 1 over square root of 2, which are same thing. Now, if you look at the next one, so square root of 3 is just square root of 3 over square root of 4 is 2. So that becomes square root of 3 over 2. And we just found that, if you remember, square root of 3 over 2. We did this one and this one already. And I know that sine 30 is 1/2. Sine 60 is square root of 3 over 2. We did that. Now 4 over 4 is 1. Square root of 1 is 1. So sine of 90 degrees is just 1. So we have values for sine, okay, sine of those special angles. Now to write for cosine, what I do is I just go in reverse order. So I'll bring that 1 right here. The next is square root of 3 over 2. I'll write it here. The next is square root of 2 over 2 or 1 over square root of 2. Next one is 1/2. Next one is 0. So that is cosine 0 is 1, cosine 30 is the square root of 3 over 2, cosine 45 is the square root of 2 over 2, cosine 60 is 1/2, and cosine 90 degrees is 0. Now to write tangent, we know that tangent is sine divided by cosine. So 0 divided by 1 is 0. 1/2 divided by square root of 3 over 2 is just 1 over square root of 3. Now, square root of 2 over 2, these two are same thing. So when you divide, you just get 1. Square root of 3 over 2 divided by 1 half is square root of 3. And 1 divided by 0 is undefined. So we don't have that value for 90 degrees. Okay. So that's how we can make a table. Now for cosecant, secant, and cotangent, you know that they are just the reciprocals and you can write them. So even if you don't remember the table, you can just in 1 minute, you can just make this table so that you have values for everything. But I have a table here. Sorry, I have a table here where we have this value. So sine 0 is 0, 30 degrees, which in radian is pi over 6. So you need to remember that as well, because sometimes you might see angles in radians. A lot of time you see angles in radians. Especially when we move on to calculus, we use radians instead of degrees. So that's what commonly used. Okay, so 45 degrees is the value. See, 1 over square root of 2, or you can also write square root of 2 over 2, and then this we already found that. So all of these are the one that we found. Okay, this one in the first quadrant, then this for 180, 270, and 360. But there are other special angles between 90 and 180, 180 and 270, 270 and 360. There are some special angles. But once you remember for the first quadrant, we can use this one and the concept of reference angle. Remember, we talked about reference angle in the previous video. So we can use that to find the values in any quadrant, okay? Just for this special angles. Now, if you have to find for 29 degrees, then we have to use the calculator, but for this one we can find exact values like this. Okay, so that's all in this video. In the next video we'll talk about the unit circle, and we'll just translate everything into a unit circle. Everything that we did here, we'll redefine those trigonometric functions looking at the unit circle, and we'll look at all these values in a unit circle where you see all of those values very nicely. Maybe easy to remember those things than remembering from the table. Okay, so that's all for this video. I'll see you again in the next video.